Good morning, I'm Shinhye Joo. I'm research associate in Western Michigan University. I'm glad to be here with you today. The subject of my presentation is assessing bicycling environment using GPS instrument pro bicycle. Let me start with my presentation. Monitoring generally means to be aware of the state of system. Monitoring is the backbone of intelligent traffic operation, control, and planning for improving mobility and enhancing safety. These three techniques is vehicle detection, vehicle tracking, and traffic performance measure the technical requirement for monitoring. This system have focused on vehicle traffic. So what about bicycle? This question is my motivation in this research. What about bicycle? How can I apply bicycle? The bicycle is an important human-powered transportation. They have health benefit and they have emission-free and environment-friendly characteristics. In addition to bicycle use, can improve air quality and can also alleviate traffic congestion. However, safety and comfort issues remain serious problem to increasing bicycle usage. This picture is near-miss condition, represented near-miss condition in uncomfortable environment. One of the fundamental to provide bicycling friendly environment is to assess whether road segment can accommodate safe and comfortable bicycle. From this perspective, the scientific and effective assessment of roadway environment in terms of bicycle perception of safety and comfort is of keen interest. A bicycle-friendly road environment needs to be provided to increase bicycle usage as a significant transport mode. However, not always. Bicycling environments still have many serious problems, such as uneven surface, pothole, conflict with vehicle and weather condition or other conditions. So, can bicycle be monitoring this environment in more intelligent manner using recent sensor technology? Previous study, we performed assessment using IMU sensor and GPS sensor. However, IMU sensor is very sensitive using or handling data. Therefore, we think about how to develop simpler method for field implementation and minimize all additional requirement for new device. In addition, you need to develop evaluation method to consider cyclist characteristic and performance. So this study attempt to detect and analyze how the bicyclists respond and interact with the roadway environment using changing in bicycle speed on the bicycling environment. This methodology section. This figure is a procedure for algorithm development. The process consists of five steps. The first step is data collection. GPS-equipped public bicycle are used to collect second-by-second speed data and acceleration data. The data represented the bicycle maneuvering according to road environment. The second step is picture extraction. The salient picture will extract as an input input for the algorithm. In this study, bicycle mobility picture extract from the bicycle speed and acceleration will use the input vector for categorizing bicycling environment. This study used the support vector machine classifier. The support vector machine classifier is well known and robust. That is widely used in the field of pattern recognition. A support vector machine was conducted for identifying whether the bicycle environment was satisfactory or unsatisfactory. Finally, we evaluate performance this algorithm. The data collection was conducted at two study sites at Ansan in Korea. The first site was composed of four sigma, and second site composed of 3 segments. Each segment is specified by the variance alignment change, crossing, and pavement condition or an obstacle. Ansan has operated a public bicycle sharing system that called Pedalo. This study used GPS tracker equipped public bicycle. In this study, 50 volunteers composed of various age group from 20th age group to 50 age group. Immediately after complete their travel on each road section, the participants complete a questionnaire by selecting questionnaire regarding their perception by selecting if each was satisfactory or unsatisfactory in terms of safety and mobility. This table is summarized. This table is summarized descriptive statistic of speed data. The average speed is shown the different each segment. This figure is presented representative speed and acceleration profile on the user perception class. In general, lower speed and larger variation were observed from unsatisfactory road segment, and acceleration shown has the abrupt change in acceleration in unsatisfactory segment. Adverse bicycle environment including uphill grade, crossing, hazard obstacle, and near miss situation lead to this observation. The collected data used to extract bicycle mobility picture. The bicycle mobility picture is divided into two groups. The first group is representative statistical measures that represented the central tendency or variation, such as average, median, mode, standard deviation, and acceleration noise. The second group, this picture is represented the area bounded between the speed profile value that are lower than reference speed and reference speed line. The bicycle speed would be affected by physical performance of bicyclists depending on age, gender, or bicycling level skill level. So we employ the reference speed. In general, an elderly female bicyclist is likely to bicycle at lower speed compared with the other bicyclists. But the level of perception in the bicycle environment was not necessarily related to the bicycle speed itself. So to take this issue into consideration in delivering BMF, this study adopted the concept of reference speed. The derivation procedure for feature based on the continuous speed profile as shown in this figure. The first step is to define and calculate reference speed. We use it to reference speed variance central tendency. Next, the area bounded between the speed profile and reference speed line is obtained. Then the sum of the speed reduction area, this area, is divided by the length of the road segment. That is defined as the normalized of the speed reduction area, as shown in this equation. In case of acceleration, we use the two reference lines. One is 85th percentile acceleration and 50th percentile acceleration. This area is defined above acceleration area, so we calculate sum of the above acceleration area shown as shown this equation. Next, the selection of salient input feature that sufficiently differentiate bicycle environment is important in developing a robust classifier. This study used Bayes decision theory. Bayes decision theory is minimize the probability of misclassification for feature selection. The overlapping area, this area represented the probability of potential misclassification. Therefore, better feature in terms of classification capability can be selected by comparing the overlapping area. Finally, we identified these 7 features that they are most effective at classifying bicycling environment based on Bayes decision theory. A performance measure needed to determine prior to bicycle environment classification. This study evaluated performance using correct classification rate. Correct classification rate means the ratio of correctly classified perception cases to the total number of perception cases. We compared the classification performance of cycling environment by the heuristic method based model and the statistical model. The heuristic method is support vector machine, and the statistical model is follow. For the purpose of comparing the performance, binary logistic regression can be applied. The dependent variable represents whether bicycle environment is satisfactory or unsatisfactory. This table is result of binary logistic regression. Correct classification rate of BLR is 68.4%. The result indicates that the proposed model categorizing the user perception of bicycle environment is a high degree of accuracy. The SVM based model outperformed the VLR-based model by approximately 7% in terms of CCR. This study proposed a novel method for evaluating this bicycle environment using GPS-based bicycle speed data. An arising issue is how to use this method in practice. A viable application is to incorporate the method in public bicycle sharing system. According to Shane's study, there are more than many bicycle sharing programs operating in many cities. In particular, more implemented bicycle sharing system employed smart technology such as smart card, GPS receiver, and GPS sensor or RFID. This feature is Korean case. Some public bicycle system in Korea has GPS receiver and GPS sensor. This technology is expected to facilitate the application of the proposed method. This figure is the conceptual illustrate of application scenario. First of all, the proposed method can be further developed as software to be embedded into onboard unit for public bicycle. And second, whenever a user public bicycle sharing system conduct a check-in or check-out, the GPS speed data can be transmitted to traffic management center. An agent in the TMC can be then monitoring bicycle environment in a more intelligent, automatic, and labor-saving manners. This conclusion section. This study attempts to develop methods for identifying bicycle environment based on GPS speed data. The proposed methods can fully exploit the benefit of the public bicycle sharing system. The suggested bicycle monitoring application can establish these strategies or paths. To develop bicycle monitoring system, it needs to consider some issue in further study and basic consideration and in terms of public bike system. We expect the outcome of this research will be effectively used to develop bicycle monitoring system. Thank you for your attention.
Thank you.